And two slightly sneaky problems here. The one on the left has an answer, the solution that looks a little bit odd, and the one on the right has a question that looks a little bit different from the rest of the ones that we've done. We'll look at each in turn. Let's start them the same way we started every single other problem. Have a look inside those brackets. Okay, I've got some numbers, 6 and 3, and some x's, 6 of them in the numerator, and x raised to the power of negative 2 in the denominator. Maybe you look at it this way. 6 divided by 3 is 2, so there's a 2 left in the numerator. Okay, let's write this one more time. X to the power of 6 over x to the power of negative 2, and that's all raised to the negative 1/2. Okay, so that x to the power of 6 over x to the power of negative 2, we can resolve using the properties of exponents. That gives us x to the power of 6 minus negative 2, or x to the power of 8. So we actually don't have anything left in the denominator other than a 1, but we have 2 times x to the power of 8. And that's all raised to the negative 1/2. Now that we can't continue inside of the brackets, let's apply those exponents. I always prefer to start with the negative exponent. It tells me to take the reciprocal of the base. What's the base here? It's the 2 times x to the power of 8. So this gives me 1 over 2 times x to the power of 8. None of that changes. The reason we're moving everything to the bottom has nothing to do with the exponent of 8 and only to do with the exponent of negative 1/2, but only the negative part of it. So the 1/2 is also still there. At this point, we take every single thing inside the brackets and raise it to the power of 1/2. So that gives us 1 to the 1/2, and 1 raised to any exponent is still 1. 2 to the 1/2, and x to the power of 8 to the 1/2. Now this one's a little bit different from our previous questions because 2 isn't a perfect square. So you can leave this as 2 to the power of 1/2, or you can write it as the square root of 2. Either is fine. I tend to prefer writing it as the square root of 2. I find that a little bit tidier. But because we can't evaluate it and get an exact answer, I'm going to leave that square root in the solution. We can resolve x to the power of 8 to the power of 1/2 by taking the 8 and multiplying it by 1/2, and that gives us x to the power of 4. One small caution here, you'll notice that I have the square root of 2, and I've really stopped the radical sign. I've made sure that that x to the power of 4 is definitely not under the radical. So I haven't been a little bit sloppy with the radical the way I was here. Another way to write this would be to put x to the power of 4 out in front and write the square root of 2 afterwards. This makes it very clear that it is only the 2 that is under the radical and not the x to the power of 4. So this one had a slightly strange answer. The next one has a slightly strange question, but it's very easy to resolve. If you don't like the fact that it's written as radical, let's look at it as an exponent. So we have 100, x to the power of negative 2, y to the power of 4, and that's all raised to the power of 1/2. Now it looks very similar to other problems that we've tackled. Once again, I'm going to resolve what's going on inside the brackets first. I've got a negative exponent inside the brackets. So that x squared gets bumped, and it's the only thing that gets bumped, to the denominator. It's all still raised to the 1/2. My properties of exponents tell me that every single thing inside the brackets needs to be raised to the 1/2. So 100 is raised to the 1/2. Y to the power of 4, also to the 1/2. And x squared to the 1/2. Let's start evaluating anything numerical and resolving anything algebraic. 100 to the power of 1/2. A little bit tricky. So 100 isn't necessarily always going to be a perfect square. If it isn't, then we do know how to simplify our radicals. Let's look at this bit by bit. So if I have a number, I'm going to write that as a radical. Square root of 100. Turns out that we have a perfect square, so we can evaluate it, unlike the case in the previous problem where we had the square root of 2. As an aside, if I asked you for the square root of 200, well, we could evaluate this as well. Although 200 is not a perfect square, we know how to simplify radicals. 200 is simply the square root of 100 times 2, and the square root of 100 is 10. So 10 root 2 would be what we get out of this. None of that matters in this case because we have a 100 under the radical. It is a perfect square. What about the y? Y to the power of 4 further raised to the 1/2 is going to be y to the power of 4 times 1/2, or y squared. And here we have x squared to the 1/2, or just x. So our final answer here is 10 y to the power of 2 all over x.